So let me briefly introduce Jaspreet Kaur, who is a postdoctoral researcher at the University of Glasgow. I actually visited Glasgow city just a few months back. We had an inter-academy workshop on 6G. So integrating Open RAN with reconfigurable intelligent surfaces enhance robotic surgery. So this is an important area, the whole RIS stuff, right? But Jaspreet, I'm expecting while you talk about the use case, maybe you can throw some light in terms of what, how it is applicable to the work we are doing in 6G and anything related to Open RAN. So we are considering also potential power on 6G as well, right? So some of the talks today are focused towards Open RAN, some maybe towards 6G. So Jaspreet Kaur is a postdoctoral researcher at the University of Glasgow, and she focuses on XApp for RIS integration since May 2024. She has previously served as a graduate teaching assistant and a PhD scholar at the same institution. And her contribution was towards research in presentation communications. Jaspreet has held part-time postdoctoral researcher roles at UCL, working on title. Okay, folks, can you, if you're not speaking, can you please mute? Otherwise, you have to mute.
Sure, Mike.
Title is your acceleration and was a visiting scholar at Arizona State University and Yotoba's Laurent University, where I don't know where is it. Her work includes research on vehicular communication, collaboration on SI 6 funded projects. Jasper on her holds PhD electrical electronics from University of Glasgow and BTech in ECE from Punjab Technical University. Past projects involve developing microfluidic chips for antibiotic permeability and MEMS-based gas sensors. So with that, Jaspreet, please take it over.
Sure, thank you so much. Let me share my screen. I'm going to share my whole screen. Hello, can you see my presentations now?
Yes, absolutely. Please proceed.
Okay,
thanks.
Thank you so much. First of all, hello everyone. I am Jaspreet Kaur, a postdoctoral researcher at University of Glasgow, and thank you so much for giving me this opportunity to present in front of you esteemed presenters. I am going to explain this short outline. Firstly, what is the motivation behind the project, then the overall system, then what we have done so far, and then how our custom apps app can leverage the Open RAN environment and future steps. So first of all, the motivation behind this project is to integrate the RIC, which is an intelligent controller for an Open RAN, with the RIS, which is a reconfigurable intelligent services. Those people who don't know what are the intelligent services. So these are the reflectors which can actually send or reflect the signals from base station to the particular UE, desired UE, and develop XApp for the robotic dentistry use case. The goal is to demonstrate an Open RAN to control the resources through RIC by integrating the RIS, developing the RIC-RIS integration on Open RAN testbed, which we have just developed in the University of Glasgow, and also developing XApps for the performance enhancement, demonstrating an overall system with real world application, which is robotic dentistry. The overall system looks like this. As you can see in this picture, that we have an Open RAN system, which is open software that we have installed on a PC, and then it can be connected with the SDR, which is nothing but a RU for us, and then it can be integrated with the RIS, which is reconfigurable intelligent surface. So what if there is some blockage between the base station and the robotic arm, which is placing at some other place? Then we can introduce the RIS, reconfigurable intelligent surface, to reflect our signal to that particular robotic arm. So the overall Open RAN principle is well known to all. So it is a disaggregated system as compared to the traditional system. So it is having an intelligent controller. It can introduce, like we can introduce artificial intelligence and machine learning algorithms to control the policies. We can reduce the latency. We can increase the data packet rates and everything. So these are the things which are giving us the possibility to work on this system, which we can't actually go along on the traditional systems because we can't manipulate most of the parameters over there. But in XApp, we have, if we are talking about in a near real time applications, then we can introduce the XApp, which can actually help us to interface many more applications, just like robotic arms. So the main concept behind it is the XApp addresses major innovation of the 6G networks, which involves the integration of RIS with the ORAN. This integration adheres to the ORAN vision by utilizing the real-time intelligent controller to manage interactions between the base station, which is a GNB, and the RIS through an app. The RIC is integrating with RIS, radio network access, via E2 interface and the protocol. If you remember this previous image, then you can see that we have the Open RAN and then we have E2 like XApp. So it is we have this through this E2 interface, we can actually talk to the RIS through our ORAN system. So the radio unit, which is a transmitting unit, can actually pass the signal from RIS to the robotic arm, or even we can use it for the multiple applications like beamforming and beam steering as well. This means that RIS can provide the virtual LOS, which is a line of sight between the radio unit in the RAN and the receiver, that is a robotic arm. And then that line of sight connection is highly needed, where we fixed our latency to milliseconds in real-time transmission. The RIS facilitates the job of the RIC in controlling robotic arm operation without delay, impacting the dentistry surgery process. As we are aware, like there are two types of modes that we can actually use for the Open RAN environment. One is the ZMQ mode, the zero modulation mode, which is nothing but a very similar to the simulation type of environment, where we can actually enable the core processor, the ENB, the RIC, and UE. We can see the communication among them, and we have tested it on our system using the shell scripts, and we successfully checked all the existing XApps through this system. Apart from that, we also enabled the USRP mode. Here in this picture, you can see that we have a PC that is acting as a EPC, which is acting as a core processor for us, and at the same time, it is also having the SRAN, the ORAN RIC into it, which is connected to our one of the SDR, which is a software-defined radio, X300. And then this X300 is actually communicating with the UE side, which later on replaced with the robotic arm as well. So currently, we are at the stage where somehow we are trying to reconfiguring this whole system because we have already tested the existing XApp. Now we are introducing more parameters, let's say data packet lost, throughputs, latency parameter, and all that things that we get that can be visualized along with the actual application done. So this is the stage where we are at now. So I have a video also to show that how we are actually working on this. But before going to show you that video, I would also like to mention that for the next further steps, we are actually going to troubleshoot all the bugs which we are actually getting right now in the USRP mode experiments. And in parallel, we are going to actually, we have already written, but we are still actually making some parameter changes, amendments to make it more compatible with it. So before going further, let me share my screen again for the video. I hope you can see that. So this is a video where,
Yeah, we can see.
okay, perfect. Let it finish so that I can describe a little bit about it. So in this video, what we are demonstrating is like we have a haptic feedback that controls the robotic arm, and then we can actually see the denture. Right now, we are only using this robotic arm to see the denture. In the future, we might be able to do the actual surgery, which is bit of a tricky part for sure. But right now, we are at the stage where we have connected the Open RAN environment, which is this system, where we have replaced this UE SDR with the robotic arm, and then we have control the haptic controller robotic arm from from one room to another room, and we got less than 100 millisecond latency. So this is what we have done so far. Thank you so much for listening. I am open for the questions right now. Thank you so much.
Please go back to the testbed slide that you were showing.
Sure.
So, right, you have SRP, SRS, ORAN RIC. Where did you get the ORAN RIC from?
So our PC is acting as a, because we are using the OAIC repository. So in that repository, we have the privilege that we can enable the same PC for EPC and for the GNB. So our SRS RAN is over there only in one PC only.
Right, right. Okay, and so how this is related to the proposal you are making, integrating RIC with RIS? I mean, you had a slide before, right? Yeah.
Yes, definitely. So right now we are at the stage, because we already have the RIC fabricated and tested everything. Now we are at the stage where, and we have already tested the robotic arm as well. So now we are at the stage where we will be integrating the RIS. So, but we are still in the process of getting some results. So the tweaking is still going on and everything. So that's why I have not introduced any results related to that. Maybe in future we will be sharing the results with you.
Okay, so I think the next question would be, so you gave a presentation, you have some good ideas, and how do you think you can bring your work or research into this IEEE, this specific community, either in Open RAN, industry connection, or 6G, or maybe combination. I think your idea kind of applies to both of the working groups right now, right?
Yes, Dr. Ashutosh, actually in the Tidal program recently in UCL, we actually make this proposal for the business point of view as well. So now we are at the stage where we are dealing with the both technical aspects and the business aspects as well. But we are still on the way. There is no concrete foundation yet. So yes.
Were you there in the morning when Dilip presented his PAR and?
Oh yes, I heard the whole conversation related to the PAR and everything. Yes.
Right, right. No, I'm just trying to see which specific category we can continue. Obviously, you don't have anything written up like Dilip yet, but this is a good area. Just like Dilip was talking about heterogeneous RIC. You are trying to see how RISC can enhance some of the ORAN capabilities, right?
Yes, definitely.
Is it just an integration? You see there are some interesting interface development, opportunity to develop interfaces. So this is a use case, right? Or this is I shouldn't say use case, this is an architecture of integration of RISC modules that can
Yes.
enable many use cases, right? I think.
Definitely. Definitely. Application could be anything, but yeah, integration would be with the RIS.
Have you written any paper on this?
Oh yes, there is a I would say a company, the 6G bricks you may have heard of. They are actually trying to do the similar things. So they are having the RIS modules and everything, but they are still in their testing zone. Like they are still testing their RIS, uh, which they have fabricated. But we have already RIS fabricated, tested, and now we are at the phase where we can just like integrate it with the ORAN. Right now we are at the phase where we are we are actually putting it into the two shelves, right? Like first shelves is like, let's say the first goal is to integrate the ORAN directly with the robotic arm, and then ORAN through the RIS. So we have almost configured it with the direct communication with the robotic arm, and now in future we will be in doing it with the RIS as well.
So do you see in Oran Alliance, I mean, the architecture set by Oran Alliance right now, is it lacking anything in terms of what kind of enhancement we need? Because I think what I'm thinking is to create a small kind of a task force who are RIS folks and, RAN folks, right? And there
Yes,
could be people from 6G working group who can maybe potentially provide expertise on the RIS and
definitely.
come up with some kind of problem statement, maybe a small white paper exactly the use case, how, and since you already started prototyping, which is a good thing, right? At least you're getting fast and experience some of the experimental problems, right?
Yes.
And you have some idea how to integrate RIS into it.
Yes, through, yeah, definitely. So we have a code developed already, the RIS X app. So we will be just integrating through the same X app, but it is still under the process. So that's why I am not able to elaborate it so well. So because I don't have any specific results related to that, but the code is already written, and now we will be just testing it over the hardware. Because when we are doing the simulation part, it works so well because it is in the ideal conditions. But when we are coming into the hardware, it gets into so many the practical and technical obligations and everything. So we are at the stage where we are actually
Yeah.
dealing with those technical things. Yes.
Alex, you want to
And
say something?
Yeah,
Alex, go ahead.
yeah, I have a question. So, would it make sense to standardize a RIS as a standalone module, regardless of how it is implemented, and define its interfaces and functionality?
I believe,
So,
yes.
so people could, and if it's a standard, you can't standardize the design. You have to standardize like an interface functionality, and then let people implement it any way they want it. So you will have your design, somebody else will have another design.
Definitely, definitely. But as I have said that we are actually using the open OAIC, right? The repository. So we are actually dealing with the cost effectiveness point of view as well, being a researcher, obviously. So through the one PC, we have like core and RAN at the same place. And on the UE side, it can be RIS, it could be a robotic arm as well. And RIS is already developed. So if we can actually, if we are saying that we are standardizing the E2 interface between the RIS and RIC, that could be the possibility, but it could be an open source code as well. So both things are feasible.
Open source and standards are not competing. Open source is implementation of a standard. It could be, right? So if you define RIS functionality and interfaces, then anybody can implement it any way they want.
Mhm.
Because
Yeah.
That's a,
innovation here is using RIS, right? That's the innovation.
Yes.
yeah,
Yes,
absolutely.
yes.
So Alex, I think that's a very good point. That's what I'm pointing out. I mean, while they're trying to come up with a prototype, and maybe the initial prototype, they might just use some ad hoc way of connecting. It would be good to have some standardized interface and protocol even, right? That
Right.
will integrate, yeah.
Right, because the value is in REST functionality. Implementation is absolutely not important. It can be, and if they have a better implementation, they'll have a competitive advantage. Others will have another implementation. But I think it has a value. It's just module standard for REST, a generic standard.
Yeah, I know last ICC, and there are like few papers probably got best papers just based on REST. Best paper award. So it's an interesting area of research. I think should be definitely of interest to both Open Run and 6G. Any question from the audience, or Mehmet, if you are there, if you have any question, and folks in the audience, maybe we'll spend 5 more minutes discussion next steps, then we move to Nishan's second talk. You want to ask? One second, hold on. We have a question from the audience. Dr. Amitabh Mishra, hold on, please.
I have one question. Have you made any measurements and that tells me that integration at the risk buys me what you claimed? Like what proof you have that risk will reduce the latency or whatever benefits? So that part I want to hear, evidence.
Is that qualitative? Something is blocked, right? So the whole idea of risk is to make sure if things are blocked out of line of sight, you can make risk to enable that communication. But didn't talk about what is the drawback of that in terms of performance, right?
I think risk has its own limitations.
Right.
I mean, its own bottlenecks. Anyway, that's it. So.
Yeah.
Hold the mic up a little bit, please.
So Jaspreet, you want to answer that question to Dr. Mishra?
Do you mind repeating the questions, please?
Yeah. Go ahead. So the
No,
question, did you hear
Yeah.
the question? Let me rephrase. So the question was, what are the benefits of RIS in terms of performance? Have you done any of those analysis?
The best advantage is it can actually cover the all non-line of sight events. So for example, if you are at one location which is not in the vicinity of that base station, then RIS can actually reflect the signals from your base station to your desired location.
Right.
And it could go until like not just from one room to another room, from one university to another university, or from one country to another country also. And definitely it can also reduce the latency to a greater extent. That is prime requirement for the healthcare sectors.
Yeah.
So these are the two things that I would say.
Yeah, why don't you ask that question, please?
But RU, CU, DU are wired.
RU, CU is wired, definitely, because they are connected to a PC, because it is just a SDR, and it is actually wired.
So I think in the experiment you have, right? But if you use like SDR, like B210 from NI, or there are many of those, right?
The 3X300, yes.
Yes. I mean, you can always have the G-Node B, and in your prototype, if you saw that, right? The way we have done it, obviously, you're just doing a prototype. Traditionally,
Definitely.
you should have over the air, right? Between.
RUA
So,
is
I'm
actually
sorry,
not connected.
No, RU, yeah, you're right. So RU, CU, they have to be wired, of course. Yeah. I mean, that's
Yes,
the
definitely.
frontal, middle, backhaul, that's fine, yeah. But are you using, what are you using over the air? Just standard,
So
between
just a
RU and the end device, you're using What is your audio? Can you show that slide?
Sure.
I just want to look at your.
Second.
Yeah, I saw it, but because we're also building something similar here.
So our RU is similar to which is an SDR,
Okay,
and
okay.
but we have replaced the SDR with the UE because the robotic arm does have the proper processor system and everything. So,
Got it. Okay, okay.
but
And-
for the sake of this experiment, we have the base station which is acting as a GUSRP and
Yeah,
the
yeah.
transmitter, let's say, and the UA is on the other hand side, which is acting as a receiver, and they are communicating
Right,
over
right.
the air.
Okay, I get it. So I think it'll be interesting when you try to inject RIS into your prototype, and you must have thought about the design aspects. And that may be a good stepping stone to get into the real requirement or potential standardization of interfaces, right?
Yes, definitely.
So my suggestion would be right now, maybe write up small like 2-page type in terms of, and you can discuss that in our next Open RAN or 6G monthly meeting, make a presentation on that. So this is just an initial introduction of your idea. And then we'll figure out, because I wanted to, for each presentation today, it will be very constructive if you know what is the next task. Otherwise, it will be just a series of presentation without any results, right? If you agree on that, Jaspreet, let's take that as an action item. And I don't know, unless Alex and Mehmet, you have any suggestions as to what is the next step for this specific presentation. Yeah.
Well, if that's idea is acceptable to standardize the rest, we can just go on and start discussing the scope. But
yeah, that is another one. We can send you the power document and at least start putting the scope there, right? That's probably an initial way of getting things done.
So I'll definitely happily actually discussing all your comments with my seniors as well, and I'm looking forward to get your next Open RAN summit as well.
Well, not summit. Summit happens once a year, but we have
Okay.
Open RAN working group meetings every month. So.
Okay.
Okay, but I'll send you a PAR. At least you start filling out the PAR. That will help focus your exact activities, right?
Definitely.
scope is most important, Ashutosh. I would start from a scope.
Yeah, the scope, yeah. So even before you fill out the PAR, just like Dilip had written a little bit of extended version of his PowerPoint version, he kind of translated that to Word version, right? That may be the first step, right? Maybe you can, I'll send you the PAR, but before you put things into PAR, try to come up with a small, like 2-3 page extended abstract version of your thoughts, right? That'd be great.
Okay. Sure.
And
Sure,
folks,
definitely.
somebody is speaking. If you're not a speaker, please mute yourself kindly for the benefit of others. Thank you.